Hi everybody, today we're going to talk about multiplicity of zeros and what their impact is on the graph. So before we can figure out what the multiplicity is, we've got to put it into its factors. So the multiplicity is the degree of whatever its factor is, whether it's a binomial, just a monomial, whatever the factor is, the degree controls the multiplicity. We'll go through what they all mean here in a minute. So before we can do that, let's factor this out. They all have an x in common. So we're left with x squared plus 10x plus 25. And so the x stays out there. Two numbers that multiply to give you 25, add to give you 10, of course, are 5 and 5. So the best way really to look at this is to say, okay, well, x plus 5 occurs twice. So x equals 0, that's the 0. Imagine this would be set equal to 0. Even though it has a name, we would set it equal to 0. And then the other 0 would be x equals negative 5. Well, x equals 0 has a power of 1, so that occurs once. X equals negative 5 has a power of 2, so this one occurs twice. In a minute, we're going to take a look at some of these graphs and what this means and looks like. When you factor and the lead coefficient is negative, you want to factor that out. And you also, of course, want to take out the highest power. So here we're going to factor out a negative x squared. That's going to leave you with x squared minus 6x plus 9. Make sure all the signs get changed. So this negative x squared stays out here. We're going to have x times x. Two numbers that multiply give you 9, but add to give you negative 6 are negative 3 and negative 3. So again, we would have negative x squared, and this would be x minus 3 quantity squared. If you have a hard time figuring out what the 0 would be, just take each factor and set each factor individually equal to 0. Or do it in your head. So the square root here, obviously you can't take the square root of 0, and the fact that it's negative is still going to make it 0 because that's how 0 works. And this, of course, occurs twice. And then here we get x equals 3, and because it also has a power of 2, this occurs twice. So what does this multiplicity mean? What is it going to look like on the actual graph? If your multiplicity is even, it doesn't matter, 2, 20, doesn't matter. The graph is actually going to bounce off of that x-axis. So the bounce could occur. Remember, it goes back in the direction that it came. So it could occur above the x-axis, so it would bounce. If it comes from below, it's going to bounce and go back down below. So a bounce means it goes back in the direction in which it came. Just bounces right off. If your multiplicity is odd and not 1, so think about x to the third. Think about that awkward pause right here at the 0 at the x-axis for x to this third. We're going to call this a slide. So it actually slides through the x-axis. And it doesn't mean that it touches the x-axis more than once. It just means that to the naked eye, we can't see the details. And for example, like 1 over 64 versus, 1 over 32, things like that. If the multiplicity is 1, and this is what obviously occurs the most often, it's just going to intersect that x-axis. It's just going to go straight through that x-axis, just, regular old up through and wherever it happens to go. So in order to draw these graphs without the calculator, you're going to need to use end behavior. End behavior will help you get a better understanding as to where the graph will go. So let's go through this multiplicity chart. And so this chart, we just want to figure out, okay, well, what's the 0? I'll slide this over here. The zeros would be, if you need to set them up equal to 0, then do so. Our 0 would be 1. It has a multiplicity of 2, right? So we're looking at this, which means the effect it's going to have on the graph is going to bounce. This one, 2x minus 3 equals 0. We get x equals 3 over 2. And so that's your 0. The multiplicity is 2, which again, this is going to bounce. And of course, this x plus 4 gives you a negative 4, has a multiplicity of 1, which means it's just going to go through or intersect, however you want to explain that. It just goes straight through or it intersects, like we called it up there, the x-axis. Now on your y-axis, we're not going to graph any points. The high and the low will be guesses. So let's put these zeros on the axis, on this x-axis. So it looks like we need all the way out to -4 over here. And we have a +1 and a +1.5. So again, this y-axis I'm not even going to mark because we're not interested in its highs and lows. Now we need to know the lead coefficient. That's what controls the end behavior. Is it positive? Is it even? Is it odd? What is it? So that's how you're going to know that. So our lead coefficient, if we just rip off like this x squared, we don't care about multiplying it out. Do not multiply it out. We'd have x squared times 2x squared times plain old x. And furthermore, we don't care about the 2. We only care about if it's positive or negative. You don't really care about the value of that lead coefficient. All we care about is the highest degree. So our lead coefficient, of course, looks like it's a 4. But the degree on that is x squared, x to the first. So this is x to the 5th. So we know it's positive and we know it's odd. Positive and odd. Do you know your end behaviors? If you don't, just remember x to the 3rd is positive and odd because you know that parent function and it'll tell you. On the far right, it's going to go up. So I know that this end is going to go up. And on the far left, I know that this end is going to go down. Now we just have to use the bouncing, the sliding, the intersecting, and see if we can't figure out what's happening. So I'm going to go from right to left. I'm going to go kind of backwards in my thinking, just because that's the order of my zeros. So it's going to hit the 1, and it's going to bounce. Now when it bounces, I don't know how high up it goes. It doesn't matter. So it's going to bounce off of this, but it has to turn around because it has to hit this, and it has to bounce off of this as well. And I don't really know the y-intercept, so I'm just going to guess. But when it goes through, it has to go straight through that -4. So these are absolute guesses. I have no idea where this is, no idea where that is. I don't know how high it is, how low it is. You draw it however you want to. So yours might look a little different. Yours might look like a tiny little bounce, and then maybe, you know, more of a smooth graph. It's up to you. We'll get to figuring out the y-intercept, and if you know the y-intercept, you certainly can use it. But we'll get to figuring out the y-intercept later, a few more days. If it's not factored, you know what to do. We're going to factor this out because we need its factors, its linear factors. So we're going to take out, I guess they're not all linear, sorry. We're going to take out the x squared, and then we're going to have left x squared minus 15x plus 56. Two numbers that when you multiply, you get 56, and when you add, you get 15, would be -7 and -8. So our zeros are 0, and that happens twice, so it's going to bounce. Another 0 is 7, that happens once, so it's just going to intersect or go straight through. And we get x equals 8, which happens once. This is also going to intersect. So the lead coefficient is a little bit easier to find, I guess, sorry, the degree with the combination of the lead coefficient. I keep saying lead coefficient, but we want both. So this ends up being positive and even, which, as you know, positive and even means both ends are going up. So again, on the graph, I'm not going to mark anything on the y-axis because it's not really what we're focusing on. I do have to go out 8, so I might want to extend this a little bit here. So I have 8. I have +7, that's super close, and then 0. So it turns out the y-intercept is 0 as well. So I know that my ends, this end is going to go up, and this end is going to go up, because it's positive and even. So let's, this time, if you want to go from left to right, if that's better for you, I'll do it this way. So I'm going to come up to the 0. It's going to bounce. I don't know how high it goes. I don't know where it turns. I'm not interested in that yet, but I know that I have to get way over here to 7, and it's going to go straight through. But I also know it has to finish up, so it has to turn around somewhere and go back up. So it's not a beautiful graph, and it's certainly not exact, but it's just a pattern of the end behavior and the sliding, bouncing, and intersecting.